video, we are going to now discuss about the classification of crystalline solids. Now, most of the solids that we find are in crystalline nature. For example, all the metallic elements like iron, copper and silver. Again, non-metallic elements like sulfur, phosphorus and iodine, and compounds like sodium chloride, zinc sulfide and naphthalene, they all belong to crystalline solids. So let us see what are the different classification and the properties of crystalline solids. Classification of crystalline solids. Crystalline solids are classified into 4 types. The first type is called molecular solids, second is ionic solid, third is metallic solid, and fourth is covalent or network solids. So we are going to discuss each type of crystalline solid in detail with their properties. The first type of crystalline solid is molecular solids. Now, this classification of crystalline solids is based on the force of attraction present in the solid, or it is based on the attractive forces present in the solid. And in molecular solids, the constituent particles are molecules. So these are the constituent particles, that is molecules are the constituent particles in molecular solid. Now, molecular solids are again classified into 3 types. So, next we are going to see the classification of molecular solids. The first one is non-polar molecular solids. Non-polar molecular solid. And in non-polar molecular solids also, the constituent particles are solids. Now, what is the force of attraction or binding force present in non-polar molecular solids? It is the dispersion or London force. Dispersion or London force. So that is the attractive force present in non-polar molecular solid. Now what do you mean by a dispersion or London force? It is a temporary attractive force that results when the electron in 2 adjacent atoms occupy positions that makes the atoms form temporary dipoles. And you have learned about this London force or dispersion force in class 11. Now, example for non-polar molecular solid is argon, carbon tetrachloride, H2, hydrogen molecule, I2, carbon dioxide. So these are the examples for non-polar molecular solids. Now, these non-polar molecular solids are soft and they are non-conductors of electricity, which means they are insulators, and their melting point is very low. So this is about non-polar molecular solid. Now the second type of molecular solid is polar molecular solid, in which the constituent particles are again molecules, but the force of attraction present is dipole-dipole interactions. Dipole-dipole force or dipole-dipole interaction. Now, what do you mean by dipole-dipole interaction? It is the attractive force between positive end of one polar molecule with the negative end of another polar molecule. For example, between 2 hydrogen fluoride molecules, we have dipole-dipole interaction. So, example for polar molecular solid is HCl, sulfur dioxide, etc. Then we have one more example, that is ammonia. Is also an example for a polar molecular solid. Now, polar molecular solids, they are also soft and they are insulators, and also they have very low melting point. Now, the third type of molecular solid is hydrogen bonded molecular solid. Now, hydrogen bonded molecular solid. What do you mean by hydrogen bond? Hydrogen bond is formed between hydrogen atom of one molecule with the electronegative atom of another molecule. So, the attractive force present in hydrogen bonded molecular solid is hydrogen bond, and the constituent particle present is molecule. Now, example for hydrogen bonded molecular solid is water. And the physical state of this hydrogen bonded molecular solid is they are hard, and electrical conductivity, they act as insulators, and the melting point is also very low. So, this is about the first type of crystalline solid, that is molecular solids, which is again classified into three types, that is non-polar, polar and hydrogen bonded molecular solids. Now, the second type of crystalline solid is ionic solids. Number 2 is ionic solids. Now, the constituent particles present in ionic solids are ions. These are the constituent particles present. Now, the force of attraction present in ionic solid is called Coulombic or electrostatic force of attraction between anion and cation. So, the force of attraction is electrostatic force of attraction. Now, example for ionic solid is, example is sodium chloride, then magnesium oxide, zinc sulfide, calcium fluoride, etc. Now, regarding the properties, physical nature, they are hard but brittle. Then next physical property is a very important property, that is ionic solids, or about their electrical conductivity. Ionic solids, they act as insulators in solid state, which means they do not conduct electricity in solid state, but they can conduct electricity in aqueous solution or in molten state, because in solid state the ions are not free to move about. So, what happens, they do not conduct electricity, they act as insulators, but in aqueous state or molten state they are free to move. The ions are free to move and they conduct electricity, and their melting point is very high. So, this is about the ionic solids. Now, the third type of crystalline solid is metallic solids. Number 3 is metallic solids. Now, the constituent particles in metallic solid is, metals means they carry positive charge. So, metallic solids, the constituent particles are positive ions which are surrounded by delocalized electrons or free electrons. So, the constituent particles are positive ions surrounded by delocalized electrons. Delocalized means free electrons. These electrons are free to move about. Now, the force of attraction present in metallic solids is metallic bonding. An example for metallic solid is iron, copper, silver, magnesium, etc. Now, the property of metallic solid is they are hard, they are malleable and ductile. Now, they conduct electricity in solid state as well as in molten state. Now, here comes a question. Why is thermal and electrical conductivity of metals high? What is the reason for high conductivity, high thermal and electrical conductivity in metallic solids? That is because of the presence of that free electron. When an electric field is applied, these electrons flow through the network of positive ions and conduct electricity. Similarly, when heat is supplied to one portion of the metal, the thermal energy is uniformly supplied to, or it's uniformly spread throughout by free electrons. So the presence of that free electrons increases the electrical conductivity and thermal conductivity in metallic solids. Again, the presence of free electrons around the positive ions is also responsible for color and luster in metallic solids. Okay, so this is about the metallic solids. Now the last type of crystalline solid is covalent or network solids. Number 4 is covalent or network solids. Now, the constituent particles in covalent or network solids is atoms. Atoms are the constituent particles. And the nature of force present is covalent bonding. So the force of attraction present is covalent bonding. Now example for covalent bonded or covalent or network solid is SiO2, silica, silicon carbide, then diamond, graphite. But the properties of silica, silicon carbide and diamond are same, but it's different from the properties of graphite. Now this covalent or network solids, as we know, they are the force present is covalent bond between adjacent atoms. So they are also called giant molecules. Giant molecules. Now, these covalent solids are hard and brittle. Why? Why the covalent solids are hard and brittle? The reason is the covalent bonds are strong and directional in nature, therefore the atoms are held very strongly at their positions. So they are very hard and brittle and they have very high melting point and may even decompose before melting. Now you know the properties of diamond. Diamond, they are insulators, it do not conduct electricity. Okay, now why diamond is an insulator? Because you know that in diamond each carbon atom is linked to 4 other carbon atoms by means of a covalent bond. So 4 valence electrons of each carbon is used to form covalent bond with 4 another carbon atoms. So there are no free electrons present in diamond to conduct electricity. So we can say diamond is a insulator. But we know about graphite. Graphite can conduct electricity. What's the reason for this? Because graphite, here the carbon atoms are arranged in different layers in case of graphite, and each atom is covalently bonded to 3 of its neighboring atoms in the same layer. So for each carbon atom, what happens, only 3 valence electrons are used to form bond, and 1 valence electron of each carbon atom is left free. And these electrons, free electron is present between different layers and is free to move about. So this free electron present in graphite makes graphite a good conductor of electricity. Also you know that graphite is soft and it can be used as a solid lubricant, because this different layers present in graphite can slide over one another due to the presence of this free electron. So graphite is soft and it can act as a good lubricant. So this is the classification of crystalline solids. 4 types. The first is molecular solid, again classified into 3 types. Second is the ionic solid, third is metallic solid, and fourth is covalent or network, or they are also called giant molecules. And here when you study the properties of covalent solids, the properties of diamond is different from that of graphite, because there is no free electron present in diamond, whereas in graphite there is a free electron which helps to conduct electricity. So with this we complete the classification of crystalline solids. Thank you.